This is an overview of the state of horseshoe crabs in Massachusetts from 3 different perspectives. This is intended as a discussion and not a debate. You will have an opportunity to ask questions of our guests after the presentations, but please keep your questions short and to the point. We ask that you also write your questions in the chat in case we run out of time before we can call on you. We will make note of your questions as possible topics for more in-depth discussions at future meetings, if there is enough interest, of course, to continue the conversation. Again, I'm Sharl Heller, President of the Southeastern Massachusetts Pine Barrens Alliance, or as we say, SEMPA. SEMPA began participating in the Massachusetts Spawning Horseshoe Crab Survey about 4 years ago. We were prompted to action after hearing Deborah Cramer speak about her book, The Narrow Edge, A Tiny Bird and an Ancient Crab and an Epic Journey. We've grown concerned over these years about horseshoe crabs, and we thought we would like to know more about the state of horseshoe crabs, particularly in Massachusetts, and start a conversation as to their well-being from people who know them best. We are very pleased to see that so many of you share our interest in horseshoe crabs. Again, thank you for being here. First, we are going to be hearing from Derek Perry. As I mentioned before, he's the Invertebrate Fisheries Project Manager for the Massachusetts Division of Marine Fisheries. So again, thank you. And Derek, would you like to start, please?
Share my screen. All right, can you guys see the screen now?
It's sharing now.
All right, you see one big screen, one big horseshoe crab picture?
Yes, we do.
All right, sounds good. So my name is Derek Perry. I'm the horseshoe crab biologist for the state of Massachusetts. And today I'm gonna be talking about my role and what I do for work. I think this moves. There we go. So my role in a nutshell is to provide scientific advice to managers. So at the state level, that means I inform my director of things going on with horseshoe crabs and how the horseshoe crabs is doing in the state. At the interstate level, I'm part of the Horseshoe Crab Technical Committee for the Atlantic States Marine Fisheries Commission. There's a horseshoe crab board. They make the rules along the eastern coast of the Atlantic coast of the United States. I'm part of a team of scientists, which includes every single state horseshoe crab biologist, as well as some other federal and academic scientists provide information to that board. I also run the Massachusetts Spawning Beach Survey. I run a horseshoe crab market sampling program. We also have an annual science committee meeting for horseshoe crabs, where each year in non-pandemic years, we discuss what's going on with horseshoe crabs. That'll be going on in April this year. If any of you would like to join, let me know. Sharl has my email and she can get in contact with me. I also review projects as they come across. If there's a wind farm or beach armoring or something like that, I'll review those projects to see how they impact horseshoe crabs. So a little bit about biology. Horseshoe crabs, we have one species in the United States, that's Libulus polyphemus. The center of their range is in Delaware Bay here. As you get further away from Delaware Bay, they're less numerous and are smaller individually. There's also 3 species in Asia. They're often referred to as a living fossil because they've been around for 350 to 450 million years. They're marine chelicerate, which means they're more closely related to ticks and spiders than the other true crabs. They live for about 30 years. And they reach maturity around 9 to 11 years of age. Males around 9, females around 11. Once they reach maturity, they'll have a terminal molt, which means they won't molt again. At that point in time, the males will have a petal pelt like this one here. They use that one to attach to the females when they're spawning, whereas the females will have legs like these. Before they reach maturity, a male will look just like this, but you can still tell the difference when they're immature based on these structures here. These structures are gonadal pores. The male is stalked here. You can see it's releasing sperm, and the female looks more like an eye here to me, and she's releasing eggs right there. So eggs are deposited in May and June for the most part. They take about 2 to 4 weeks to hatch. At that point, they look like this, just miniature horseshoe crabs without a tail. They'll molt a few times, which this one's doing right here in the first few years of their lives. Each year they'll molt a few times, and they'll shed their hard parts, and this soft horseshoe crab will pull out of that old shell. It'll swell a little bit and grow. That'll happen a number of times, about once per year after they're 4 years old. At that point, you can tell if it's a molt or dead crab by looking at the edge of the prosoma here. If there's a slit, this is where the crab walked out its old shell and left the old hard shell behind. This will not be a dead crab. If it was a dead crab, this seam here would not split. They return to the beaches, mostly in May and June around here at 9 to 11 years of age. This one here is a newly mature male. He's lighter in color, doesn't have anything really growing on his shell for the most part. This is an old female. She's in the back here. There's a bunch of things growing on her. Her shell's dark. The outer layer is sloughed off a bit. So she's been around for a while. These guys are in competition with people for food. They eat mostly shellfish and worms, and people like shellfish too. So at one point in time, there's a bounty for these guys. These are from annual reports from different towns on the Cape in Massachusetts. This is from 1960 from the town of Chatham. In continuing the fight against the predators, we destroyed over 100 bushels of conchs, over 50,000 horseshoe crabs, and several bushels of round winkle spawn. And then from Duxbury, in late June, 4 cents was paid for each live horseshoe crab delivered to me. The response was so great that in 3 days, over 14,000 crabs were received, and the money set aside for this program was spent. So even back then, people were killing horseshoe crabs in fair numbers. As recently as 1998, some towns had in their shellfish regulations that you should kill horseshoe crabs. For example, Yarmouth in 1998, no starfish, horseshoe crab, green crab, conch, moon snail, or oyster drills shall be returned to the water. They should be placed above the high water mark or suitable place out of the water. So things have changed quite a bit since then. Horseshoe crabs also have a number of predators themselves. Crangon shrimp, blue crabs, herons will eat a lot of the smaller ones. Even other juvenile horseshoe crabs will cannibalize other ones. Once they get bigger, they have fewer predators. Things like smooth dogfish, tiger sharks, turtles will eat them, but there's not much predation once they reach over 1 year of age. No talk about horseshoe crabs will be complete without talking about red knots. They're an endangered species under the Endangered Species Act. They're threatened. About half the population stops in Delaware Bay in May. And they'll spend about 2 weeks there, doubling their weight, mostly eating horseshoe crab eggs. Some of them will travel over 20,000 miles. And the harvest of horseshoe crabs, the numbers you're allowed to harvest, is tied to both horseshoe crab abundance and red knot abundance. And it's estimated in Delaware Bay, collectively, that shorebirds eat 500 tons of eggs per year. There are 2 fisheries for horseshoe crabs. One is for biomedical purposes. The blood is used to make a product called LAL, Limnaeus amoebocyte lysate. It's used to detect gram-negative bacteria, so things like E. coli. There are 5 labs in the United States that produce this. There's also a few in Asia that produce a similar product based on the Asian horseshoe crab blood. These crabs are returned to the water if they're harvested for biomedical purposes only. There's a 15% mortality estimate for that fishery. There's also a bait fishery. It's used as bait for whelk and eels. About a quarter of a crab is used per pot by the fishermen. And where once they used mostly all horseshoe crabs, now it's a bait medley. They'll use some horseshoe crabs, some green crabs, some mussels, some fish, things like that. There have been some efforts to make a synthetic product, but so far it's been ineffective. And there's a 100% mortality rate in this fishery because they chop up the crabs and put them in the traps. There's 2 ways they fish for horseshoe crabs, mostly. One is hand harvest. Guys will go around little skips like this, just pick up crabs, mostly during the spawning season, and sometimes in shallow embayments year round. The other fishery is the dragger fleet. Horseshoe crabs are collected as bycatch in the fluke and squid fisheries. This used to be the biggest fishery we had for horseshoe crabs, but now it's actually this one. More than half our fishery for landings is now from the mobile fleet. In 2020, there was 4 active fishers that collected for biomedical. There's 2 different permits for horseshoe crabs. There's a biomedical and a bait. So the guys who have a biomedical permit can't sell for bait. Guys with bait can't sell for biomedical. There was 4 that fished for biomedical crabs in 2020 and 48 for bait in 2020. We don't have the 2021 data yet. So if you go on the ASMFC website, you might see a figure like this. It'll also be in the compliance reports that we have to send annually. So I've highlighted this red box because I don't have much faith in this part of the data. At this point in time, there's a 1-ticket system where just the fishermen reported their landings. After that, there's the 2-ticket system where the fisherman report and the dealers report. So there's a way to kind of look them together and see how they match up. So we have a lot more confidence in this set of the data. The biomedical firms have also been bleeding since the 1970s. You can see here, there's no biomedical landings in this period, which is untrue because they were landing in that period of time. So what we have here is the bait landings collectively across the entire coast, so the Atlantic coast. You can see about 1 million horseshoe crabs are taken each year for bait. This blue lines, the bars here, are the biomedical landings. Now, these are the ones that are brought to the lab and then bled and then released back into the wild. The mortality from that bleeding is these small little bars here. So oftentimes, if you Google horseshoe crabs, you'll see articles about how the horseshoe crabs are being bled dry by the biomedical companies. But if you look at this data, that's simply not true. The bigger harvest is actually the bait. The smaller one is a biomedical. But there's a number of ways to try to keep those horseshoe crabs in the biomedical firms alive so they return in good shape. There's best management practices. This was adopted by both scientists and the biomedical firms. In Massachusetts, we take those BMPs and make them requirements on their permits. So basically, each year we send ACC, which is a biomedical firm in Massachusetts, we send a list of things that they have to do in their permit to keep their permit. One is keep their crabs separated by source. Another is return the crabs in good condition. It's not really specified what that is, but it's in there. They're marked annually to avoid rebleeding, so you can't bleed the same crab twice in 1 year. They're transported between 50 and 60 degrees Fahrenheit in refrigerated trucks. In the lab, it has to be less than 70 degrees. And the containers, such as this barrel here, have to be less than 2/3 full, so you don't crush the crabs in the bottom. The crabs have to be kept moist, and my agency or the environmental police can inspect the facility at any time. They also have to report the number of crabs they bled by sex and the condition of those crabs. And they report that monthly. Another thing we do is we go into the lab and we measure the crabs. We'll look and see if there's any changes over time. So what we have here is each one of these little bars is a year. On this side, we had the prosomal width, which is the width of the crab. And this is in centimeters. So what we have here is these black lines are the median size for that particular year that we measured. This is the 25th percentile, 75th percentile. This is 1.5 times the interquartile range. And these little dots are outliers. So basically what I see here is a fairly steady across the board median size. That's a good thing. That's what we want to see. There's a few outliers like 2013, both for females and for males, but it's fairly steady. So that's a good thing. This red line here is a minimum legal size, which is 7 inches or about 18 centimeters. This is landings for bait. This red line here is our state quota, which is 165,000 crabs. You can see we exceeded that in 2019. This data point here is from 2021. It's preliminary because sometimes they do change a little bit based on QA/QC, but generally the landings have been increasing for the last decade or so. This is where landings come from. Most of it comes from Nantucket Sound. There's hand harvest here, but there's also, this is where the fluke and squid fisheries operate. So that's why most of the harvest is coming from there. There's smaller amounts in Buzzards Bay, but there's no dragging in Buzzards Bay. It's illegal. So we don't have that much landings over there. A little bit from Vineyard Sound. And there's 12.5% of our state landings from 2020 anyway, came from the area of North Cape Cod up to the New Hampshire border. If you look at monthly landings, the biggest landings month is May, but we do see more extended landings throughout the season, where prior to recently, it was mostly May and June, but now it's kind of a more prolonged harvest. And most of the harvest outside the spawning season is done by mobile gear, so those draggers that we saw earlier. But during the spawning season, it's mostly hand harvest by guys going along the beaches getting spawning crabs. So we also go to the bait markets to look at the crabs to see how they're doing, see what the size is. What we want to see is kind of straight across. We're not quite seeing that in the bait market. This line here is the size of sexual maturity for crabs based on studies done in New Jersey. So it's about 10 inches here. What we're seeing is that prior to 2014, we were mostly above that line. These median sizes are mostly all above. All that sampling was done during the spawning season, when it's believed most of the harvest was coming in. After 2014, we started extending the sampling season into later in the year. What we're seeing is a drop here. So this is a little concerning to me. This means to me that we're seeing more juvenile crabs in our fishery. Males are fairly steady, not quite so bad, a couple down years here or there, but mostly steady. Yeah. So if you look at this by month, what we see is the size is close to size maturity in May and June. That's when the spawning season's going on. That's when guys are harvesting them off the beach. But come July, when there's no more harvest off the beach, we're seeing this decline in size. This is when the dragger fleet's operating. And we're seeing a drop in female size about 1.5 inches, and for males about 0.5 inch over time between the spawning season and later in the year. So regulations, ASMSC sets statewide quotas and regulations along the coast. They give us 330,000 crabs to harvest annually. You can see the numbers for other states as well. Some states around Delaware Bay, they look at their quotas annually. For the last few years, it's been a male-only harvest. That's what these marks mean. For mass regulations, we can be more restrictive than what ASMSC dictates. We can't be less, but we can be more restrictive. We took that quota and basically cut it in half to 165,000 crabs. And we also have permit restrictions, meaning if you want to harvest bait by hand, you can't get a permit to do that anymore. That was outlawed in 2008. We also have a rent-a-crab program. Biomedical harvesters cannot sell to bait harvesters, and bait harvesters cannot sell to biomedical facilities, but a bait dealer can sell crabs to a biomedical dealer as well. So they're taken from the bait market, sold to the biomedical firms, they're bled and sent back to the bait market. This is basically a more efficient use of a resource. There's a 1,000 crab limit for biomedical harvest daily, 400 for bait harvested by hand, and 300 for bait by mobile gear. If you don't have a permit, you can harvest 6 crabs without a permit. There's currently a 7-inch minimum legal size, and you can't bait lobster pots with crabs. Basically, why that's there is because people are starting to bait lobster pots with horseshoe crabs to get around their conch pot limits. You're allowed only a couple hundred conch pots, but you're allowed 800 lobster pots. So some guys are starting to bait with horseshoe crabs. So that was outlawed. You also can't bring in Asian crabs from Asia to lessen the likelihood of bringing in introduced parasites or diseases. So in addition to those regulations, there's also area closures. This green area here is from the National Seashore. The blue area here is Monomoy. Those are federal closures. And there's a state closure for Pleasant Bay here. Only biomedical is allowed in this area. They've been harvesting there since the 1970s. We also have lunar closures. Crabs can come up on the beach during these yellow shaded areas here, and they're allowed to spawn without being subjected to harvest. And there's a bunch of different times where that happens. There's also weekend closures, Fridays and Saturdays, in the dragger fleet where they can't catch crabs during this period of time. Aside from the fishery, there are other population concerns. One is eutrophication. This is something we see on the south side of the Cape a fair amount in the salt ponds, where there's dense algal mats. These are areas where the crabs can't spawn anymore, and they can't forage because these dense mats come over here and just blanket everything. That's caused by excess nitrogen in the water. We also have beach armoring. This is an issue for crabs because if they want to build a nest over here, the waves will come smash off this wall and scour out those nests. One of my personal pet peeves is beach grooming. This is something we saw at the beach that I survey in Wareham, where the peak in spawning is usually May and June. Then in late June, before the 4th of July, these guys would come through and rake all the beaches to get ready for the tourists. Well, if you're doing that during low tide, you're going right through areas where horseshoe crabs have laid eggs. We've talked to the town of Wareham, where I've personally seen this a fair amount. They've agreed to stop doing that. So hopefully other towns will follow suit. There's also dredging. Horseshoe crabs use channels to wait for spawning and overwinter. So if you're going through and dredging a channel, you're going right through prime horseshoe crab habitat. So there's some stock assessments that are done at the Atlantic coast level. What we do is we have a data workshop, and states and other groups present data. It's a very intense process. Then there's a stock assessment subcommittee, which is a subcommittee of the technical committee for ASMSC, as well as other stock assessment biologists. They go through that data, parse it out, and write a report. That report gets sent to the technical committee, which I'm part of. And basically every single horseshoe crab biologist at the state level, from Mass down to Florida, will have to approve that document, as well as all the other federal and academic biologists. If that's approved, it goes to independent peer review, people outside the TC and outside the SAS, these two groups here. And then they provide their report. That all gets sent to the Horseshoe Crab Management Board for management decisions. And it's quite a big process. If anyone wants more information, you can access it right here. And all the old horseshoe crab stock assessments are also available here. They're generally done every 5 years. The first one was done in 2009. At that point in time, the New England region was considered poor, which we're part of. So Massachusetts, being proactive in some regards, did some regulations before 2009 and some after. Those included a permit moratorium, lunar closures from May and June. There was 5-day closures around the new and full moons. The quota was cut in half. Possession limits, daily possession limits were cut by 60%, and also area closures were added. During the 2013 assessment, we were still considered poor, so Mass added new regs then too. They extended the lunar closures to include the second half of April and further reduced possession limits. So the 2019 assessment was the most recent one. The Northeast region includes Rhode Island, Massachusetts, New Hampshire, and Maine, but basically there's not much data north of Cape Cod, so that really wasn't included, basically just Rhode Island and Mass. And at this point in time, we were considered neutral. Our surveys in this state were showing a big increase in crabs, whereas Rhode Island was not. So that's why we're kind of 1 out of 2 here. This is looking at the number of surveys that are doing poorly. So 1 out of 2 was doing poorly, 4 out of 4 in New York were doing poorly, 2 out of 5 in Delaware Bay, none of the Southeast ones. Coast-wide, there was 7 of 13. But if you look at where those occurred, it's basically 5 in this New York, Connecticut, Rhode Island region. Everywhere else is doing fairly well. This is the first time biomedical mortality was used in a stock assessment. That 15% mortality rate, that was based on literature and other tagging efforts and modeling. Biomed mortality was considered modest. It was 87% less than the bait harvest. So again, like I mentioned before, if you go online and look up horseshoe crabs, you'll see all kinds of misinformation about what's going on. But if you really want to know what the status of horseshoe crabs are, I highly recommend looking at the stock assessment reports. It's approved by every single state horseshoe crab biologist up and down the coast. That's the most accurate information, in my opinion. Discard mortality was a concern. Basically, what that means is when the dragger fleet's out there dragging up crabs, they'll let some of them go. They think there's a high rate of mortality on those ones that are let go. The results of this assessment led to new regulations in New York and Connecticut, where they were seeing a decrease. And the next assessment is scheduled for 2024. So these are the surveys from Massachusetts. This is done by my agency. This is a trawl survey where we drag around a big net and basically go across the state and see how many crabs we catch. This side is females, this side is males. Top panel is a spring, bottom panel is fall. This red line is a time series median. This line is a lowest smoother, it's a trend line. And this shaded area here is a confidence interval around that trend line. These dots are individual data points. And what you see in the spring here is we're having a big increase. We've never had as many crabs as we've had recently. This is a 40-year time series. We've seen the same thing with males. In the fall, it was going up. It's not quite going up as much as it was before. It's kind of come down a little bit, down towards the time series median. Females, Gulf of Maine, that last one's for just south of Cape Cod. It's just north of Cape Cod now. Seeing the same increase in the spring here, coming back down a little bit in the fall period. Now moving on to the spawning beach. We have 17 different beaches that we use. And they're all over Cape Cod and some off the Cape here. And there's a number of different organizations that help us with a survey. The survey is done. It's based on a survey done in Delaware Bay. They use a 1 by 1 meter quadrat. We go 5 by 5 because we have fewer crabs than they have. So this is for Buzzards Bay at night. Basically, there was more crabs at this point in time. It's kind of leveled off. But the last data point, 2021, is kind of around the time series median. For Cape Cod Bay, we have a big peak in 2013. Modest little increase here, but not much. I should actually mention that some of the data we have for 2021 isn't in yet. So the ones from the eastern side of Cape Cod Bay, that's still going through QA, QC. So this figure here is just for one spot in Barnstable and one spot in Plymouth, Kingston, Duxbury Bay. For Nantucket Sound, this is where most of the harvest is. We're seeing an increase here. Outer Cape, this is where most of the biomedical harvest is, also seeing an increase here. Again, 2021 data is not available yet, but my understanding is that 2021 is another strong year for that area. So to summarize, horseshoe crab abundance in mass is generally increasing, possibly due to previous management measures, but attention is still needed due to increasing harvest and declining size of landed individuals in the bait fishery, as well as environmental conditions. If you'd like to participate in the spawning survey, you can email me here at this address provided. If you'd like to provide public comment, at certain times, there'll be new regulations that are proposed. If you want to be made aware of those, you can sign up here, and there's a box you can click for horseshoe crabs. So if you just want to be notified of when horseshoe crab things are coming about, you can sign up here. I'd also recommend signing up for fluke and whelk because those will also influence horseshoe crab landings. You can report tag crabs. This is an old tag from the U.S. Fish and Wildlife, has a phone number you can call. There's also a newer tag, which has a website. It's pretty easy to enter the data. I'd like to thank a number of different organizations that have helped with the spawning beach survey, as well as the many dedicated individuals who've helped with the survey. And thank you. I'll take any questions if I have time.
Thank you so much, Derek. We're going to hold questions until after all of the presentations.
Okay.
Make sure we get everybody in.
Okay.
Thanks so much.
No
Next up, we have Brett Hoffmeister. He is the LAL manufacturing manager for the Associates of Cape Cod.
Okay, once I'm unmuted, we should be good to go. All right, so thank you very much for the intro. Again, my name is Brett Hoffmeister, the LAL manufacturing manager. I also serve on the advisory panel to the Atlantic States Marine Fisheries Commission, currently as chair. It's my pleasure to be here today, and I really appreciate the invite. So quickly, the agenda is really going to talk a little bit about the company I work for, a brief history of endotoxin testing, and what is LAL? How does it work? Exactly what is it used for? The role that the horseshoe crabs play in this industry. Some talk about sustainability, particularly our project, and the future of the horseshoe crab and endotoxin testing. So we've got a lot of material to cover. I'm going to do my best to keep it within the time frame. Please bear with me. So Associates of Cape Cod is really a pioneer in this industry. It was our founder, Stanley Watson, that first commercialized LAL back in the 70s. So we have nearly 50 years of experience in what's called endotoxin testing. We have a facility right here in Falmouth, Massachusetts. And we have a global reach of over 75 countries. We are also the first successful large IVF program for horseshoe crabs. I'm not aware of anything else in the world that does what we're doing, although Maureen can be credited with doing a great job. We have the ability to do some IVF in a large scale operation. We're also most recently the first to offer a full recombinant cascade, so RCR. We're going to talk about that. I'm going to throw out a lot of acronyms and stuff like that throughout the presentation. I hope to make these more understandable. So a brief history of endotoxin testing takes us way back to the development of antibiotics and whatnot. And there was a very real risk when early in the days of what was called injection fever. People were getting sick from getting antibiotic injections. And that spawned a whole new industry of pyrogen testing. So it was important to understand why people were getting sick from that. Pyrogen testing was really using rabbits to substitute human bodies. What would happen, let's say a company was making a flu vaccine. They would inject a rabbit with a sample of the flu vaccine and wait to see if it got sick or died. Now this would take days. It also sacrificed thousands or tens of thousands of rabbits, if not millions. And the test wasn't always real accurate. There was other things that might make a rabbit sick. You all see the commercials and the possible side effects from things where rabbits are very sensitive. So when you got a sick rabbit, you weren't really sure it was because of the medicine itself or a side effect from this endotoxin that might be there. It also wasn't qualitative. You couldn't tell if it was a lot or a little bit. Of course, it was conducted on animals. In the 1970s, after a lot of research on the horseshoe crab blood, again, our founder of our company was able to license LAL with the FDA. So it was in around this time, almost 40 years later, that there was a major shift in endotoxin testing. The LAL test proves to be more reliable, it's less expensive, it's faster, and of course it doesn't use rabbits. So there was a great deal of benefit to doing this. And now we're on the forefront, we think, of the new future of endotoxin testing with recombinant technology. And we're going to talk more about that. I think a lot of you here today have heard about things like RFC and recombinant products. We believe that this is going to be the future of endotoxin testing. Recombinant technology is animal, and I think eventually will be horseshoe crab free. It is in process of being accepted by global regulatory agencies, and this is a very complex process. So exactly what is LAL? We'll take a step backwards a little bit and realize that limulus amoebocyte lysate, the acronym for that is LAL. So limulus is derived from the Limulus polyphemus, the American horseshoe crab, and LAL is an extract from those crabs. The amoebocytes are the cells within those crabs that serve to protect the crab. It's their immune response to exposure to bacteria, and specifically gram-negative bacteria. They contain the enzymes that we use to make our products. And lysate is the process of helping to make that. So the lysis of cells really means that the cells are, through osmosis or exocytosis, releasing those enzymes and proteins that we're after to make our products. So LAL stands for the blood from the American horseshoe crab that's lysed. So how does LAL work? Well, the reality of it is that horseshoe crabs live in a sea of bacteria. And if they're injured in the wild, their blood will contact the gram-negative bacteria and a clotting action begins. There's a cascade that forms almost immediately. Factor C kind of wakes up the immune response in the horseshoe crab, and a clot is formed. And that clot isolates the endotoxin. It also releases inhibitors to tell the rest of the blood, okay, guys, we got this. Don't everybody clot at the same time or this horseshoe crab's going to die. I mean, that's a simple way of putting it. And then healing begins, similar to if you cut yourself shaving, you bleed, the blood slows down, you form a scab, then you begin healing. There's a cascade that happens. LAL tests use that reaction in a qualitative assay. So there's 4 basic tests for that utilize horseshoe crab. There's a gel clot, which forms a gel. There's a turbidimetric test that that looks for turbidity. We can start to look at the qualitative assay and look at the turbidity. And then there's a chromogenic test where the lysate will change color. So we utilize that cascade and we can manipulate it. We can do things with it, speed it up, slow it down. We can make it change color. And we actually have a product that detects fungal infections. So the picture here just kind of shows some of the LAL, the buffers that we use, the equipment that we use, and the software that's run. This is a fairly complex test. It's a very important test. So what is it used for? What makes it important? Well, LAL is used as a test for the potentially lethal contamination of bacterial endotoxins. That's a mouthful. So let's start with, what are endotoxins? Well, endotoxins are compounds called lipopolysaccharides. They're derived from the outer cell wall of gram-negative bacteria. So things you're probably familiar with are E. coli, salmonella, but there's a litany of gram-negative bacteria out there. And the lipopolysaccharides, or LPS, only exist on gram-negative. It is not on gram-positive. These endotoxins are pyrogenic. So we go back to what I said earlier, pyrogen testing. They cause fevers. So endotoxin is present everywhere. We're surrounded by it. As I'm talking, I'm putting endotoxin all over this room. It's really only dangerous when it gets into the blood wall or spinal fluid. So obviously E. coli can make you very sick, but if that E. coli gets in your blood or spinal fluid, it can be lethal. LAL helps to ensure the safety of injectable products and indwelling devices. So I can't understate the importance of this product. The primary applications of LAL are injectable and indwelling materials. So things like drugs and vaccines, childhood immunizations, insulin, flu vaccines, chemotherapy drugs. If you've ever been to a dentist and had Novocaine, if you've been to the hospital and had an IV put in your arm, if you have a hip replacement, these are all things that were tested using LAL. That they need to make sure that they don't have endotoxin in it. As I mentioned, knee replacements, heart stents, heart valves. Again, if they get into your body, it can make you sick and potentially kill you. Anything injected or implanted in the human body must be free of endotoxin. This is so important that it's mandated by the FDA, and in fact, it's the law. The final testing of these things before they're for sale or before they go into a human body have to be done by law. And it's safe to say that just about anybody that you meet in your entire lifetime right now has benefited from LAL. And you need to digest that for a minute. And I'll say it again. Anybody that you've met in your entire life or will meet in your entire life has benefited from this process. So modern medicine is miraculous. And this is an important addition to that. So we know crabs are used, but how are they harvested? And I'm going to breeze over this very quickly because Derek covered a lot of it, but there's two basic fisheries, the biomedical and the bait. The biomedical is a dedicated fishery where crabs are returned to the water and they're marked. We use a non-toxic paint to mark these crabs to make sure that if a fisherman catches them again, they can see that paint and they put them back into the water. Crabs that are targeted for bait are also part of the bait fishery, as Derek mentioned. They're bycatch. Utilization of this resource for the biomedical industry is endorsed by the statewide managers as well as coastwide managers. Crabs are returned to the vendor, and therefore it gets the Rent-A-Crab program tag. It's an easy way to kind of describe what it is we're doing. It often gets confused. We are not in the business of selling crabs for bait. We never have, never will be. But we can utilize that resource because it's really a conservation effort. The end result is that less crabs are harvested. Handling the crabs, as Derek mentioned, there's some B&Ps that are longstanding industry practices. The simple ones are that we keep them moist and keep them wet. I mean, it's obvious these are marine animals. They need to come out of water. We keep them wet. We keep them healthy because a sick animal is no good to us. Animals that come in damaged and stressed or have been left out of the water for a long time are already triggering a response. We can't use that. So we take a lot of effort to take good care of them. In the lab, we keep them in a cool space. And as Derek mentioned, we check for size and health. We record their sex, and unusable crabs are recorded. Typically, we return them to the vendors within 24 hours, oftentimes much sooner, particularly on a Friday afternoon down the Cape. Nobody wants to deal with the traffic, so we try to get them back quickly. Reporting on every crab that enters the facility is required. So this goes to the state, and the state in turn takes that data and gives it to the statewide managers. So every crab that biomedical companies use is recorded. In the lab, again, we don't collect the crabs, they're delivered to us. The blood collection itself is fairly simple. It's fairly quick. You guys have probably seen videos and pictures on the internet, But we keep the crabs in that dark area until it's time to bleed them. When they come into the lab, we inspect them for health, we check their size, make sure they're legal, and then we put them in a rack that exposes this membrane on the prosoma. They're going to fold into a naturally defensive posture. It exposes this membrane, and that membrane gives us access to a sinus that surrounds the heart. So we don't puncture the heart, we don't take all the blood out of the crab. The majority of the blood is going to stay in the crab. We take very little, actually. What the pictures that you see on the internet of containers filled with blood, that's primarily an anticoagulant solution. The blood goes into an anticoagulant solution, it stays suspended, and then we centrifuge it. What we're after is those amoebocytes, as I mentioned earlier. So the majority of the blood is a hemolymph that ultimately is waste. We need to get those amoebocytes. So we centrifuge it, then we wash those cells. We want to get that anticoagulant off once we've isolated it, and then we burst them through that process of lysis. We burst those amoebocytes. We release the enzymes and proteins that are in it, and that's the raw material. We have a liquid that goes into refrigerated storage that is the basis for the majority of our products. There's a number of things we have to do afterwards, but that's basically what we put into inventory. Of course, the crabs are returned. The process of getting the blood out of the crabs is relatively quick. They're going to spend maybe 15 minutes to a half hour in the lab, and then they go back into the cold storage, in the dark storage, before they get returned to the vendors. Now, there's a lot of excitement about what we call our Horseshoe Crab Sustainability Project. This is really a part of a much larger system, but it is the first large-scale in vitro fertilization of horseshoe crabs. This utilizes crabs from the bait market. So this is another benefit of that Rent-A-Crab program, that we can, and we've worked with the vendors, we talked to them and talked to the bait fishermen or the dealers and said, hey, do you mind if we take a few teaspoons or a few grams of gametes from the males and females? We're going to make more crabs. And they told us to go right ahead. Ultimately, these are not our crabs. We borrow them. We began this in 2017 with a proof of concept process. I know Dr. Dan Gibson's within the audience here. He was invaluable to helping us with this process. He showed us how to do it. We were successful. We started doing it in Petri dishes and small tubes, and we were successful. The company backed this up. It was really a project I was involved with. Really very exciting. We got some additional funding and we were able to scale up the operation and ultimately come up with a system that we applied for a patent. It's currently pending, but it's something I'm very excited about. Before we could release crabs to the wild, we had to apply for an aquaculture permit for the state. They issued us a one-of-a-kind permit to release horseshoe crabs. Just a reminder that horseshoe crabs are a consumer of things. They're predators. They eat clams, they eat mussels, they eat oysters. So the state wants to keep an eye on where we're releasing these crabs. We just don't put them on top of somebody's oyster grant. So we've got this permit that has a lot of conditions attached to it. In 2019, I had the privilege of traveling to China. There was an international meeting of horseshoe, people concerned about horseshoe crabs, and we donated a system to the Islamic University of Malaysia. We were seeking other people interested, and unfortunately, COVID kind of derailed some stuff. But I have systems on pallets that we are donating to systems and organizations so that they can raise horseshoe crabs over in Asia, where the Asian horseshoe crabs are not monitored. They're in trouble compared to the ones in the United States. So we're trying to do our part in helping crabs halfway around the world. Very happy to be part of that program. Again, this program is really neat. I encourage you to look on our website. We've got video of that. I provided some links. Hopefully you guys will look at this, but these are the eggs that we fertilize. This is Sam and Sarah, who can be credited with helping develop this process. This was early in the game. And we were raising the eggs in Petri dishes and learning how to do this. But ultimately in the lab, we can monitor the eggs. We can fertilize these eggs, and the ones that are fertilized successfully, that develop, it's a fascinating process. This is a picture we took with the microscope, or actually I think my phone, but these eggs swell up, they burst from their outer shell, and these castings are clearly visible. And what emerges is this beautiful crystal clear ball with a horseshoe crab inside. And in the video, you can see these animals moving around, turning, growing. It's really neat. It's as fascinating as it is alien. Once they reach that stage, we're able to sort them. We can sort the successful fertilized eggs. We put them in these these are called McDonald hatching jars. They circulate water through that. They use these in salmon farms, trout farms. We use them to incubate these eggs and hatch them. And what you see in the water column here is crabs that have hatched. And this is almost like Jiffy Pop popcorn. First there's one, then there's two, and you turn around and there's 500. It's really neat. And these crabs will emerge in the course of a day or two by the thousands. They swim up the water column, they exit the McDonald jar, and we can catch them in a net that's submerged in a tank. Once we catch them, we can prepare them, start to prepare them for release. We grow them out into these grow out trays. So there's about 5,000 crabs in each one of these trays. After about 2 or 3 weeks, they'll grow out into their second and third instar. So at this initial stage, which we'll call the trilobite larvae, they have yolk. They're surviving off that yolk. They're swimming around. They're very active. They're fun to watch. But in the wild, they're in the water column. In the wild, the majority of these crabs they're not gonna make it. They're gonna be eaten by fish, by birds. They're gonna be tossed up on the shoreline. And it's not until they grow a little bit, become benthic. When they reach that second and third instar, they grow their telson, they become benthic, and now they have fully formed mouth parts and they can feed. So this is an important stage in their life where now they're going to burrow down into the sand, they can eat, they can protect themselves. So their chances of survival are exponentially better at this stage. And it's at this stage that we release them. And as I mentioned earlier, we release them into protected embayment so they have a good chance to survive. They're not subject to, wide open ocean, things like the Bass River, East Bay, and Great Pond and Falmouth are areas where we release them. And we literally release these by the bucket load, generally about 20 to 50,000 at a time. This was a release in Bass River, and you can see these just thousands of crabs pouring out of these buckets. And I'm delighted to say that in 2021, we released our millionth crab. So the video on our website actually shows that release on that day. That was late in July, but it's a big number. I'm very proud of that. So what is the future of endotoxin testing and recombinant technology? Well, there's a lot of talk about things. Recombinant technology is really animal-free. Recombinant endotoxin testing is horseshoe crab free. So recombinant products are not necessarily anything new. I mean, in the timeline of human existence, they're very new, but recombinant human insulin has been used for some time, but it wasn't that long ago. We used pigs and cows. We were able to extract insulin from their pancreases. Now we manufacture that through recombinant technology. So similarly, recombinant factor C, that clotting agent, the beginning of the cascade that I talked about earlier, I'm sorry, it's not the clotting agent, it's that trigger mechanism. Factor C was reported in 1995, so we were able to isolate that. And the first commercial use of that, the RFC, was in and around 2003, that relied on that single factor. And as I mentioned, it doesn't clot, it doesn't provide turbidity. You need to add fluorescence to it, and you need special training and equipment to read that fluorescence. So the substitution for this for LAL wasn't necessarily easy, and there's regulatory concerns. This is something new to the market, and endotoxin testing, as I stated, is very important. To make an error in endotoxin testing, the cost is enormous. The cost is human lives. So regulatory concerns are very real, and the industry moves very slow because of that. We want to be very careful to make sure that we're protecting human beings. 2015, a recombinant cascade reagent was introduced. So this is not just the recombinant factor C, it's a more complete cascade. This was done by our parent company, and it was using the genetic sequence from Tachypleus, so one of the Asian horseshoe crabs. And this was referred to as RTAL. This utilizes a more complete cascade. I'm going to talk a little bit about that in another minute. 2021, last year, ACC took that technology and we applied it to make our own product, the RCR, recombinant cascade reagent. And this is from the American horseshoe crab. So this is utilizing enzymes from the Limulus polyphemus, the American horseshoe crab. It's a kinetic assay, meaning it measures the energy. We can watch, we get a movie of the reaction and not just a picture of the final state. It's a chromogenic reaction, so we can add those reagents to it to make it change color. The important thing from our standpoint is that it uses the same readers as LAL. So customers that are currently using our chromogenic reagents can use the RCR without the need for additional equipment, additional training, or additional reagents. It's a like for like. I need to be careful saying that. It can be used the same way our chromogenic reagents are being used. So that's kind of our tagline in marketing this. You can keep your method, you can make an impact by not using horseshoe crab blood in this particular product. So naturally sourced LAL, this is the reaction I'm talking about. This is the cascade. When endotoxin triggers an LAL reaction, factor C wakes up all these other factors. So this is the factor C. And this is what was cloned for RFC. In a natural LAL product, we have the factor C triggering factor B, the pro-clotting enzymes, and now we start forming that clot, and you either have a clotting product, a turbidimetric, or the chromogenic. Those are your three basic LAL tests. With PyroSmart Next Gen, the RCR, we've cloned the factor C, we've cloned factor B, and we've cloned the pro-clotting enzyme. So we've got three complete factors. We've also removed factor G that reacts to glucan, which can be a pyrogenic. It's a product of fungus, and it can give you a false positive. So that's been removed. This is also a chromogenic reaction, so it doesn't clot up fully. It's not great for a turbidimetric, but with those chromogenic substrates, we can use that for our chromogenic assays, again, using the same material. So ACC looks at sustainability a number of different ways, and always been that the whole is greater than the sum of the parts. It's within our operations. You'll recognize that we recycle over 1 million gallons of water a year. We recycle materials. Of course, we work with regulators and fishermen to try to lessen the footprint our industry has on the ecosystem and the fishery. Education opportunities, webinars like this, and visiting schools is something we routinely do. And horseshoe crab sustainability projects, that should be plural. I mean, aside from our rearing of it, we like to support things like the bait bags, the lunar closures, other things that help sustain the horseshoe crab populations. And our products we're using more and more recycled packaging. And of course, most recently, our recycled recombinant technology. So sustainability is important. It can encompass a lot of different things, but we have responsibilities within the umbrella of sustainability. We need to sustain the healthcare industry. We need to sustain our employees, and we have responsibilities to the community, the ecosystem, the future. And what is the future bringing? Well, right now we have quality products to the pharmaceutical industry. We need to reduce, and we encourage a reduce of naturally sourced LAL, and we can do that through scale up of pharmaceutical products, or reduction of use in things like chromogenic or RCR. We have our sustainability projects and recombinant technologies. At least for the time being, LAL is going to be continued to use to ensure patient safety. So the end game, before it gets used, you're going to use LAL. Other things like recombinant technology are going to be able to be used for in-process materials, things like that. But right now, LAL is still going to be the compendial test, the one that's required by law. It's important to remember that populations of horseshoe crabs in the US are measured by the tens of millions of animals. Studies have shown the mortality is extremely low. They talk about the 15%, but the studies that actually utilize our processes or closely mimic our processes, and the studies that use horseshoe crabs, and I'll cite David Smith's recent study with the Geological Survey Service, shows that mortality is extraordinarily low, if not better than wild or the controls. Regulators and scientists closely monitor this fishery, and conservation effort works. Some of Derek's presentation pointed to the 2009 when they identified a downward trend. They made changes, and we've seen a reversal of that trend. So be comfortable knowing that there's teams and teams of scientists looking at these animals, and the efforts that we're putting in place or they're putting in place are working. So with that, I'm a little bit over my 20 minutes. I apologize to Deborah Cramer, but please visit us on our website, look at us on LinkedIn, and look for our video for our millionth horseshoe crab release. And again, thank you very much.
Brett, thank you. You did run a bit over, but I think everyone will agree that it was something we all wanted to hear about. Deborah, be sure to unmute yourself. Next up, our final guest speaker today is Deborah Cramer. Probably all of you know of her. She is the award-winning author of several books, most relevant here being The Narrow Edge, A Tiny Bird, An Ancient Crab, and An Epic Journey, published by Yale University Press. Deborah, thank you so much for coming.
Thank you, Sharl, and thank you to the Southeastern Massachusetts Pine Barrens Association for bringing us together for this important conversation. Brett and Derek, it's nice to meet you sort of in person. And you compressed a lot of information in a very tight space. I'm not sure I'm going to actually be able to follow that. Halota, Manamet, and Mass Audubon, we're all grateful for your longstanding work on shorebirds and horseshoe crabs. And thank you to the rest of you for joining this. The need to conserve, restore, and protect horseshoe crabs and the shorebirds that depend on them is increasingly pressing. Today, and I guess I'm going to apologize for this, I'd like to offer you a slightly different perspective on the issues we face today. Horseshoe crabs live in the waters of coastal Asia and along the eastern seaboard of North America. Just a second, I can't get this to, oh. Here we go. The Asian horseshoe crab, Tachyopletus tridentatus, once flourished in large numbers along the shores of Japan, the People's Republic of China, Taiwan, Hong Kong, and Vietnam. Land reclamation and demand of the crab for food, chitin, and the biomedical industry depleted it. Where hundreds of thousands of horseshoe crabs once came ashore to spawn, now there are few. Tachyopletus tridentatus is facing relentless and unremitting anthropogenic threats, including increasing demand, driven by, among other things, the projected growth of the amebicide lysate market. This comes from the IUCN, the International Union for the Conservation of Nature, which tracks trends in wildlife worldwide. The IUCN has listed Tachyopleus as in danger of extinction, with 90% population losses in Hong Kong, 90% losses in the People's Republic of China, where it has been listed as endangered. And it has also been listed as critically endangered by Japan. The reason for this is that the horseshoe crabs in Asia are used by the biomedical industry and then sold to restaurants and into the chitin industry. The regulations in Asia have been much looser than they are in the United States. The point that I am making about this is that as populations plummet in Asia, the pressure here in the United States on the one remaining population of horseshoe crabs is immense and will increase. A small number of US companies once made lysate. It was Derek or Brett who mentioned that Associates of Cape Cod, founded by Stanley Watson, was begun in his garage in Falmouth. But now that horseshoe crabs are commercially exhausted in Asia, those small American companies have been purchased. So 4 multinational, multi-million or multi-billion-dollar companies are taking horseshoe crabs in the United States to make lysate. These companies are Fujifilm Wacko Chemicals, a Japanese company operating out of Virginia, Lanza, a Swiss company manufacturing lysate in Maryland, Charles River Labs, a multinational US company making lysate in South Carolina and also using blood from Delaware Bay, and Seikogaku, a Japanese company, which is the parent company of ACC. Now, I'd just like to briefly examine the US context for the pressure of horseshoe crabs and where Massachusetts fits into this. So coastwide, the take of horseshoe crabs is, as Derek mentioned, is escalating. The take in Massachusetts is increasing more rapidly than the coastwide increase. Between 2015 and 2019, there was a 40% increase in the coastwide take of horseshoe crabs, a 47% increase in Massachusetts. And last year, which was a kind of weird year because of the COVID, it was a 51% increase. So, I'm sorry, 36%. So now Massachusetts takes more horseshoe crabs than any other state along the eastern seaboard. It's up to 20% of the coastwide take. And in Massachusetts, that share increased to 36%. So Massachusetts is a really big player in this. And I'm kind of not sure that these firsts, taking the highest number of crabs statewide, escalating our take faster than anyone else, in 2019 exceeding our quota, are things for us to be proud of. Now, the biomedical take is a little bit different, but it is also rapidly increasing, quintupling since the industry's early years. By 2020, the biomedical take, which was at least 700,000 horseshoe crabs, had exceeded the bait take. So bait and biomedical are both increasing, and we're taking more than anyone else. Massachusetts takes more than anyone else, but I think its regulations, and a number of us think its regulations, are weaker, and the tools it uses to measure population trends aren't as robust as those used in other states. And Derek and Brett and I could discuss these 2 points for probably way more than an hour, but today I'd just like to suggest that there's a different perspective on this, and Massachusetts can and should strengthen its monitoring and regulation of horseshoe crabs. The question is, does it matter that we're taking so many? I feel that the losses here, if you take a broader, longer perspective, are palpable. There are those of you out here today who no longer see horseshoe crabs spawning in large numbers, or really any kind of numbers, on beaches that the Commonwealth once considered major spawning areas: Duxbury, Plymouth, Wellfleet Bay, Pleasant Bay, Bourne, Barnstable, Chatham. As Derek mentioned, horseshoe crabs in the 1960s in Chatham and Duxbury were taken by the thousands, brought still alive to downtown dumps where they would die. 500,000 horseshoe crabs were killed annually as part of the quote unquote predator control program in Massachusetts in the 1960s. And then in the 1970s, they started being fished for bait. And now, despite what the ASMFC says, the IUCN is listing the American horseshoe crab as vulnerable to extinction along its entire range. For me, this is a tragedy. Horseshoe crabs are 450 million years old. They have survived each of the planet's mass extinctions, making it through when the dinosaurs didn't. We see them once a year in the spring when they come in on the full and new moons to spawn. And they don't deserve this kind of depletion from humans whose time here has been so much shorter. It's not only the horseshoe crab that is affected. Long before a species disappears, it can become what is known by the scientists as functionally extinct. A better way of explaining that is that horseshoe crabs are an essential thread in the web of life along the seashore, and now their critical contribution has been severely diminished. You saw a slide of loggerhead turtles from Derek. Loggerhead turtles are listed under the Endangered Species Act as threatened with extinction. When these baby loggerheads grow up, their preferred prey are horseshoe crabs, which they can't get anymore because there aren't enough of them. This slide, prepared by the Horseshoe Crab Recovery Coalition, which is a coastwide partnership of organizations along the eastern seaboard seeking to restore horseshoe crabs. And they let me borrow this slide. I'm not a member of the coalition, but they let me use this. Show the tiny forage fish, the killifish, the silver sides, and also for up here, it would also include mummy chugs that feed on horseshoe crab eggs, which in turn feed larger fish, including the summer flounder and the juvenile striped bass, which are important fisheries in Massachusetts. This slide is only really a portion of the food web, which is strengthened by horseshoe crabs. Here, for example, is a roseate tern, an endangered bird that nests in Massachusetts, and it feeds on the silver sides that feed on the horseshoe crab eggs. Many shorebirds, at least in the olden days, at least 20 species depend on the eggs of horseshoe crabs to fuel their long distance migrations between South America and the Arctic where they breed. And you can see a few of them in these photographs, and some depend on the horseshoe crab eggs directly, and some, like the semi-palmated sandpiper, eat the eggs directly, but then also eat the sand shrimp that you saw on the other slide, also eat the eggs. Here's another bird, shorebird, the ruddy turnstone, that depends on horseshoe crab eggs. Horseshoe crab eggs are the most energy-rich food of migrating shorebirds. They can't get enough to gain the weight they need to make their long migrations, and so their numbers are tanking. According to new data being prepared by Environment Canada and the Southeastern Massachusetts Pine Barrens Association neighbor, Manomet, an international leader in shorebird conservation and home to the International Shorebird Survey, these declines are severe. The semi-palmated sandpiper down 42% since 1980, sanderling 86%, the ruddy turnstone 90%, dunlin 95%, short-billed dowitcher 97%. And I'm told by my colleagues in Canada that in the next couple of years, some of the birds on this list are going to be put on Canada's endangered species list. And I would argue they should start being considered as threatened here as well. The larger point I'm trying to make is that our beaches are emptying of shorebirds and our seashores are growing silent. This is the red knot, already listed as threatened on the US Endangered Species Act, under the Endangered Species Act, and endangered in Canada and several countries in South America. Manomet's new data says that this bird has declined 95% since 1980. Fish and Wildlife Service's new status update just this year says that the red knot numbers are still, quote unquote, depleted with no sign of recovery. As I said, there aren't enough eggs for them to eat. There are lots of other problems as well, which are not the subject of today's conversation, but this is one problem that we can address. The migrations of knots and the other birds I mentioned across the length of continents are like climbing a ladder, each rung a necessary way station on a long journey. The Massachusetts rung on this ladder needs repair, and replenishing horseshoe crabs faster is part of it. Thousands of red knots once came through here in the spring in Chatham, Nauset, and Wellfleet, where they were eating horseshoe crab eggs. And as recently as only 20 years ago, shorebirds migrating north here were still showing a preference for horseshoe crab eggs when they could find them. Massachusetts is in the unique position of having the potential for resuming its position as a critical way station on the way north and also on the way south. Thanks to the prodigious research of Brian Harrington of Manomet and the International Shorebird Survey, we know now that not that long ago, red knots stopped on Western Cape Cod Bay in the thousands on those beaches and tidal flats that used to host so many horseshoe crabs as people were taking them away by the truckload and sending them to dumps. Not that long ago, these returning shorebirds were eating horseshoe crab eggs in July and August on their route south when the eggs were and the larvae were still in the sand. They could again if we would pause and allow their numbers to expand. So how can we return more horseshoe crabs to our beaches? Every horseshoe crab taken for bait dies. In Massachusetts, horseshoe crabs are used to bait eel. Even the ASMFC acknowledges that eel are depleted and the IUCN considers them endangered. Horseshoe crabs are also used to bait whelk. In Massachusetts, whelk are depleted. 2012, none of the female whelk left in Nantucket Sound, where a lot of the industry is based, were sexually mature. The most recent assessment shows they are still depleted and the regulations are still not tight enough to leave sexually mature females in Nantucket Sound. Those regulations won't kick in until 2029. So the question that I'm raising is, why are we killing horseshoe crabs to kill other depleted species? Why are we using an animal that's been essential for human health as bait? New Jersey halted its bait fishery, as has South Carolina. Massachusetts could do that also to protect the crabs, the shorebirds, and human health. Until recently, the horseshoe crab blood assay, as Brett has explained, has been the only assay protecting people from potentially dangerous bacterial contamination in vaccines, IV-delivered drugs, and implanted medical devices. Demand for lysate has grown exponentially since its adoption, and the demand for endotoxin testing continues to rise. Recognizing the value of horseshoe crabs to human health, South Carolina banned its horseshoe crab bait fishery years ago. Again, Massachusetts should do the same. Horseshoe crabs are a public resource important to humans and wildlife. We need to monitor population trends more thoroughly. We need more transparent accounting of where the horseshoe crabs are taken, how many are taken, and how they are used. And we need tighter, auditable, best management practices for the biomedical take that will reduce its mortality. And lastly, we need to reduce the amount of horseshoe crab blood used for endotoxin tests and accelerate the use of recombinants. There are 3 recombinants on the market now, including, as Brett mentioned, the new one offered by ACC. Eli Lilly began switching to a recombinant 3 years ago. And today, with FDA approval, the company tests its new drugs with RFC, including its COVID immunotherapies. Most importantly, it uses the recombinant in its manufacturing, which requires no regulatory approval. Eli Lilly, in the past 3 years, has reduced its need for horseshoe crab blood-derived lysate by 90%. So this is my hope for Massachusetts, that we will impose a moratorium on the bait industry, that the pharmaceutical industry will follow Eli Lilly's lead. Once again, our beaches will be filled with spawning horseshoe crabs. I don't think we would ever see it quite like this, but there's a long way to go here and to make sure that happens. Thank you.
Thank you, Deborah, and thank you, Derek and Brett, to appreciate all of your presentations today. And we have about 20 minutes for questions. I'm going to ask you that if you have a question, please put up your little hand sign. And I would like to start with Brian Harrington. So Brian, if you could unmute yourself, and when you ask questions, please direct your question to one of our 3 guests. Thank you.
I guess I would direct my question to Deborah. You touched on the indirect food chains that take advantage of horseshoe crab eggs, things such as crangon, the grass shrimp, which are an important food to shorebirds, many kinds of fish, and so forth. Do you know of any work that's monitoring the down food chain effects of horseshoe crab harvesting?
Not here. We're not doing very much research here. When I was able to put together the role of the horseshoe crab in the food chain here, what I basically did was I went to the federal courthouse and I went through, it took me 4 days going through all of the documentation that was presented when there was the lawsuit asking Associates of Cape Cod to stop taking horseshoe crabs from the National Wildlife Refuge and the National Seashore. And it was in those boxes that I found all of the connections that Carl Schuster had mentioned and that a bunch of other scientists had mentioned. But I don't think anybody is studying that now, and I think it's a loss.
Thank you.
Can I answer that?
Sure, Derek. Like I said before, I didn't want this to turn into a debate. I prefer that we answer questions and perhaps pick up these different topics at another time when we
I
have
just
more
wanted to point that we do have that data. We have surveys that do have that data if someone's looking for it.
But that show the downstream effect of,
I haven't looked at we have data on Krangon shrimp, weak fish, like a number of those species that you showed. I haven't looked at them personally, so I can't tell you what the trends are, but there is data that for those species, yes.
well, we would love to see it then.
Okay.
Great. I see a hand up for Roger Killiger.
Kligler, yes, thank you very much. Very much enjoyed this. I used to be a counter in Tahanto Beach and never saw very large numbers of crabs there. But I had two questions, and I don't understand if we're still allowing bait fishing, which I'd like to see disappear. Why aren't we collecting all of their blood and decreasing the numbers that are collected from the biomedical industry? And the second part is, will ACC continue to do IVF even when they switch over to recombinant technology to help support an industry that they impacted, or fisheries that they impacted? Thank you very much.
And who are you asking that of?
I'm sorry, Brett.
Thank you, David. Great question. So I think the first one was related to why aren't we using more of the bait crabs? And I guess,
Yeah, the Renner crab.
Yeah, simply put, the amount of bait that's harvested far exceeds our capacity to do it. Most of the crabs, I think, as Derek pointed out, May and June, it's a big bell curve. So we simply don't have the capacity to take on 100% of what comes through the bait market. So the few biomedical fishermen that are out there give us some stability. Different sources provide stability to our industry. So, but long story short, bait crabs, huge numbers come in very quickly. Regarding the IVF, I don't know. I mean, the recombinant product it's not going to be like a light switch. So the switch over is going to take years. It's not going to happen next week, next month, or next year, but it will happen. During that transition, yeah, certainly. I mean, I have no plans to shut this down. The company's invested a great deal of time and money in that, so I anticipate that we'll be doing this for some time.
Terrific, thank you. I'm not
So
seeing.
that sounded like a no. You won't continue after you're no longer directly impacting it to try and bring the fishery back up to the level where it was before the harvesting.
It's not a no. We will continue to do this for many years. Whether the impact needs to be measured, and bring it back to what? I'm not sure. Right now, some of the surveys are suggesting we've got more crabs than we have ever had since we started measuring them. So the question of, are you going to bring it back? Then I would have to say, bring it back to what? Certainly we'll continue to do this and help participate in the conservation of the animals. And hopefully, the program, crabs survive and we help the genetic diversity. But we will be doing this for more years.
Thank you. Since I'm not seeing hands up right now, I'm going to go to the chat where Denise Bush and Mark Verity have been speaking back and forth on a question. And Mark, would you like to say hello and share what it is you do?
Sure. Thanks, Sharl. Can you hear me?
Yes, very well.
Great. I was actually flailing around trying to figure out how to put up my hand. Like I haven't done Zoom a million times. We use Teams at Mass Audubon. So thanks for having this. This is really interesting. And I love seeing the different perspectives. I'm the science coordinator at Mass Audubon, Wellfleet Bay, and we've been doing spawning surveys there since before my time, more than 20 years, including data that's gone into some of the seminal papers on Massachusetts Cape Cod horseshoe crab populations. And then I did have a couple of comments, thanks to Derek and Brett and Deborah for great presentations. I just want to make a point about the data, the way Derek presented it, with increasing trends for spawning surveys. I think that was an artifact of combining very different embayments together. And so you have embayments like Pleasant Bay and Nauset Estuary combined with Cape Cod Bay, making it look like the Cape Cod Bay is increasing. And it's a really important point. And Sharl, you guys work in Cape Cod Bay, the Duxbury surveys, none of those are increasing. None of the Cape Cod Bay spawning survey data shows an increasing trend, and that includes ours at Wellfleet Bay. And so we've been hearing about the trawl data that Derek talked about, which is a general trawl for groundfish and other things where horseshoe crab are a bycatch. It's not particularly good at surveying for horseshoe crabs, but that's the only data that goes into that ASMFC stock assessment, which is this recent stock assessment makes it seem like we're improving in Massachusetts, largely because of some increases south of the Cape. But the Cape Cod Bay data did not get included in that because the trawl survey data for Cape Cod Bay is just not statistically strong enough to be included. And so Cape Cod Bay is not represented in the stock assessment. We are seeing the continued flatlining, very, very low, very close to zero spawning indices for our Cape Cod Bay spawning beaches. And you can see that at Duxbury and Wellfleet. So I just wanted to make that point because that was very unclear from the way the data were presented by Derek. We have a lot of concern for Cape Cod Bay horseshoe crab populations, and we would love to see a moratorium like Deborah was talking about. I know Derek wants to respond. Hey, Derek.
Go ahead, Derek.
Can I respond to that?
Yes,
I
please.
just want to show those slides one more time that Mark was talking about.
I was trying to paste some graphs into the chat, but it didn't work.
Hold on one second. Oh, hold on. We'll bring up the slide again.
Mark, you would be welcome to share your screen.
And Mark, I have your slide if you want me to show it for you.
Well, these were actually Derek's slides from
Oh.
last year's summary. Let me see if it works this time. No, it doesn't seem to work.
Hold on one second. So Mark, you talking about this one here? Can you see it?
We can't see your screen
sorry.
right now.
I have to share first. Got it?
That's night.
Right. So is this one you're referring to?
I thought there was just a general, like a Cape Cod Bay day. What is the day one?
I've
look
seen
like?
that one. I've shown you that one in the past. I didn't show it this time because I don't have your data, basically.
For 2021, you don't,
Correct.
but all
Correct.
the other years.
Correct.
Right.
So
But if you
basically
look at,
so basically what this one is just Duxbury and Millway at this point in time. So once I have your data, I'll include it in this one as well.
but our data is in there through last year.
Not for this. This one is just those two sites. So I'm comparing apples to apples over the entire time series.
I see.
So usually you're correct. Like usually I show these things at the conference we have every year where I include the Wellfleet sites. And because Wellfleet does day surveys pretty much at all their sites, I usually show the day surveys, but that's not here because I don't have that yet.
All right, let me just, maybe I can quickly share my screen to show what are actually your figures from last year, just to show what I was talking about. Thanks to Sharl for letting me do that. Can you see mine now?
Yep.
So this is just what I'm talking about. If you look at, this is the trend over time. And again, this is Derek's graph, DMF's graph. This is Duxbury. And you can see just, here's zero. here's all the counts. An important point, and Deborah was doing a good job of showing a larger perspective of, the Delaware Bay numbers versus ours. And if you compare their spawning densities, their spawning indices to ours, they're 1,000 times higher than ours oftentimes. And still New Jersey saw fit to ban bait harvest altogether, and the rest of the fishery went to a male only. Meanwhile, Massachusetts, we have 1,000 times lower density of crabs and a higher ASMFC quota. You cannot explain horseshoe crab management to an outside observer coming into this cold. It just makes zero sense. We have a higher quota assigned to Massachusetts than to Delaware Bay, where they have 1,000 times more crabs. And then our data is, that's Millway, Long Pasture, and then here's our daytime data. Definitely not increasing. So we're not seeing that apparent uptick that the Cape Cod Bay trawl data is seeing. So we're sort of like, what is the deal with the supposed uptick? Because we're not seeing it on our beaches, and we've been surveying them for a long time. So that was just the point I wanted to make, and I will stop sharing. Trying to speak for Cape Cod Bay.
Thank you. Don't see anybody with their hand up at the moment, but I do notice that Abigail.
Dan Gibson.
Oh, okay. Let me just say here for a second. Abigail Costigan is on this group, and I just wanted to say I was inspired to hold this forum after reading her blog that she wrote while she was working with Mass Audubon. So Abigail, I didn't know if you wanted to just say a few words, but I certainly wanted to thank you for that inspirational and very informative blog.
Hi, thank you so much. I'm really glad to hear that. Hi, Mark. Mark was my boss when I wrote that. And yeah, this talk has been really great. I feel like getting all these different perspectives is really interesting. And thank you, Deborah, for inviting me to this.
Thank you. And I'm sorry, Deborah, who did you say had their hand up?
Dan Gibson.
Oh, yes, there it is in the corner. Thank you, Dan.
Just got to unmute there. Well, hi, Derek and Brett and Deborah. Great talks all. And I have a question for Brett about the production of LAL necessary for this surge in vaccine production. And it seems to me that because you're testing batches, that this is actually not as big a drain or a catch-up procedure to make enough testing material for all the different solutions and for testing the vials and stuff like that. So is that, am I reading that correctly? Brett, are you there?
Yes, I had to unmute myself. Morning,
Oh,
Dave.
okay.
Yeah, so that that's been something that's been widely speculated and debated whether or not COVID was going to impact, the collection of the horseshoe crab. So again, not an easy one to answer. It's rather complex, but simple answer is not really, no. Pharmaceutical companies have the ability to scale up, and a single vial of LAL can test 1,000. A batch that can make 1,000 vaccines, you can also test a batch that makes 10,000. So the scalability of the industry itself is key to that. That's one of the things that they would typically do. You could use it to test a liter of water, or use the same test to test 10,000 liters of water. So scalability helps. Also, the fact that the reality of it is with COVID impacting a lot of hospitals, people weren't going in for a lot of surgeries and things like that. So there was also a decline in use on another end. So it wasn't like the hospitals saw a sudden increase in COVID and facelifts and knee operations and stuff like that. If it wasn't necessary, it didn't happen. So we did see a decrease in the market on a lot of them.
Right.
I think that scalability is really key.
There are countless articles that imply the idea that the LAL is a component of the vaccine. But in other words, you have to have some LAL in every vial, and that really gives a false impression of the additional volume of stuff that might be needed. Now, I just wanted to mention also that Bill Sargent, whose name comes up now and then, has mentioned in a recent talk for the Rhodes Scholar Foundation that the LAL companies are now scrambling to make as much LAL as they can before the new RFC comes in, because they know that their industry is going to go broke as soon as the RFC testing is fully approved. What do you think of that? Sounds to me like you're going to land on your feet.
Yeah, I don't know that I would necessarily agree with that statement. I'll keep it, yeah.
Yeah. Okay. Well, I on the surface, I think it's preposterous. I just so that's all. And just while I've got the floor, I wanted to say one worry that I have is when horseshoe crabs are no longer necessary to produce this life-saving stuff, they are going to lose some of their cachet. And people are going to, perhaps beachgoers particularly, regard them as pests when they come into spawn. It's as iconic as they might be, having a beach with 1 million dead crabs per per linear mile, which is what Botten and Loveland estimated down on Delaware Bay, is not something that you always want to see when you go to the beach. And they do, a lot of them die. So it's just a little worry that I have about the animal that we want to save, that we also keep reverence for it in mind. I don't know if everybody's going to do that. So thank you.
Thank you. Brian, I see your hand up. Did you have a question?
Well, I just wanted to make 2 points. One is that historically there evidently were huge numbers of horseshoe crabs in Cape Cod Bay. Some of the naturalist accounts from the late 1800s refer to red knots in Cape, presumably in the spring, on Cape Cod Bay, in clouds darkening the skies that were eating the eggs of horsefoots. And that was mostly on flats around Billingsgate in Cape Cod Bay. The other point I really wanted to make is that I think the downstream effects of reduced numbers of eggs is already happening. I'm seeing many fewer grass shrimp on the flats in the Monomoy region, in Pleasant Bay, and I'm not counting them, unfortunately. I'm counting birds. But just as a general impression, for over the last half decade or so, the numbers of grass shrimp that are bumping into my feet have declined enormously, to the point where last summer I was actually seeing very few grass shrimp, which used to be a mainstay food for many of the birds using the Bay region, Pleasant Bay region. Okay, that's just 2 comments, and I'm done there.
Well, I'm going to call on Denise Bush next, and then Carol, definitely you. I see your hand up. And I would like to hear from Maureen. Maybe Maureen will help us leave on a brighter note. So I hope. Anyway, Denise, would you like to ask a few questions? I see you've been active in the chat.
Sure. My name is Denise Bush. I work for a local small nonprofit called Deploy US, but I am attending this on my personal time because of my interest and care about the region's environment. I live in Plymouth, Massachusetts, so this is very close to home. I just wanted to say thank you to Deborah, Brett, and Derek. And I also wanted to point out that I'm really impressed with the willingness of Brett and Derek to come to this, because I know it's not always easy to take criticism in these questions, but it does show, great courage to show up and come here and talk about these issues, because it's clear that we all do care about the environment and the horseshoe crab population. So thank you. Thank you very much for having us and having me here.
Thank you, Denise. And
Thank
I
you.
certainly, feel the same way you do, and appreciate Brett and Derek coming to speak with us. Carol? What happened to Carol? Carol, you're still muted.
Mute.
There
Can
you
you
go.
hear me now?
Yes, thank you.
All right, thanks to
Daryl.
everybody for such a wonderful forum. Oh, I see Dan. Dan, I have to just say to you, hello, and
Hello.
also to say that it will be a wonderful day when we reach that point when they are considered to be pests all over our beach. And let's deal with that if that can happen. But I just wanted to also add, if I could, as a longtime observer, layperson, that if the general public is watching this as well and want other information, you can also go to the Horseshoe Crab Recovery Coalition site and look at their goals. And a lot of them will be exactly what you heard Deborah speak about. You can also tag into defenders discussions. And I just hope what people take from this is the overall look about where we are and where we have been. I've been observing since the 1990s, wrote many articles for the Cape Codder magazine. I had to use a pen name because fishermen were threatening and calling me. This has been going on a long time. The cast of characters is perhaps different, but it's the same problem as ever. So I'm hoping, as Deborah says, and all of you, that there is a foreseeable future that's a good one for the species. Thanks a lot to everybody.
Thank you. And there are so many people on this meet that I would love to hear from and know what your involvement is. So I hope that you will join us again when we have future discussions. And Maureen, can you bring us to a happy ending? Nice, something hopeful, and you're muted, so send us off with a positive message if you can, Maureen.
All right, efforts are underway to designate the American horseshoe crab, who's a resident off our coast, as we all know, to be a mass designated symbol of an invertebrate marine species. So Senator Sy is working, and his group are working to make that happen. So look forward for more on that in the months ahead. And also I'd like to encourage everybody to remember that June 20th is International Horseshoe Crab Day. So whatever organizations or groups you belong to, we do encourage them to mark it and highlight it in some special way, because the first two were overshadowed by COVID, and efforts to celebrate were greatly inhibited from doing anything extraordinary. So, so far, the Division of Marine Fisheries via Derek, the Mass Audubon with Mark Fahey, and other, the Cape Cod Museum of Natural History are all planning special events during that week or on that day. So I invite everybody to participate in some way.
Maureen, thank you. Couldn't have asked for a better ending to this meeting. And thank you again to our three speakers. I know this was a big part of your Saturday, and appreciate your taking the time with us, people who are, kind of late to the scene, but still find themselves concerned about horseshoe crabs. Thank you so much. And if you send me an email, I will make sure that you know how to access this video and any other information. My email is simple. It's slheller@comcast.net. And you can probably also find me if you registered through the Eventbrite app. So again, thanks so much. And let's keep in touch.